charting a course from exploration to a sustainable cislunar ecosystem. So with that, I'll turn it over to Jim Myers with the Aerospace Corp. Jim?
All right. Well, thank you so much. Good morning, everyone. And it's a real pleasure to be here from the Aerospace Corporation. Jim, turn your mic on. Good point. Thanks, everyone. Good morning. Jim Myers from the Aerospace Corporation. And really looking forward to the panel today. I will say that the last two panels were really, really good, I thought. We're going to bring it down a little bit in terms of talking about technology, talking about hardware. Those two panels, though, I thought they were, they really demonstrated a sense of unity, of purpose. They were open and transparent. You got some pretty interesting answers to questions. I really want you to ask us questions. Questions were great on those two panels. I got a lot of value out of it. Also share with you that yesterday I was at a conference in Virginia, in Chantilly, entitled the International Security Space Forum. Not the National Security Space Forum, but the International Security Space Forum. You heard from the last two panels, there was a lot of discussion about international. And the first panel was specifically about Artemis, which has a huge amount of international activity in it planned. And so, so much of what we're going to do in space is going to be with allies and partners. And so I'll come back to that, and we'll talk more about that. At that forum yesterday, Cislunar came up, space traffic management came up, commercial came up. So the themes are the same. Doesn't matter whether you're kind of here talking about what I would consider civil space, you know, NASA focused, or space in the aggregate, national security, international security. Space, at least from my point of view, is the ultimate global commons, right? This is something that we want to secure, be safe, be sustainable, be stable. That's what was discussed yesterday. And in the midst of an environment where we're in a great power competition, at least that's how some people describe it, these alliances, these partnerships globally become that much more important. So what I saw yesterday were, if you've heard the terms, the 3 Eyes countries, the 5 Eyes countries, the 5 Eyes plus 3, that's who participated. It was really, really nice. So you had, obviously, US, UK, Australia, Canada, New Zealand, Germany, France, Japan. Very, very encouraging in terms of where our space enterprise is going. So today's panel, from exploration to a sustainable cislunar ecosystem. I already used that word sustainable. At Aerospace, we've given this a lot of thought. Cislunar is something that we aren't really operating in today in a sustainable way. We obviously are doing things. Artemis 1, fabulously successful mission. And you heard, if you were listening this morning, the quote, 268,563 miles. So the furthest away one of our space vehicles has ever gone, and of course came back. So the next frontier in space exploration, as far as we're concerned at Aerospace, is Cislunar. Serves as a test bed for technology, serves as a proving ground for travel to the moon, to Mars, and then hopefully beyond, right? Artemis 1 proved that the moon is within reach. We've been there. It's been 54 years since I remember. I was really, really little, but since I remember the astronauts landing on the moon, walking on the moon. And now we're getting ready for Artemis 2. You heard Jim Free talking about Artemis 3, Artemis 4, Artemis 5. We're going back to the moon. We're going to need infrastructure. So when we talk about sustainability and Cislunar, you need infrastructure. You need power. you need space situational awareness, you need comms, you need navigation. So this group, this esteemed group, is going to talk to you about those infrastructure elements and the work that they're doing to make that all possible. So I'm really excited to have this conversation. I'm going to spend a few minutes introducing them only because some of them you might not find out that much about them on the internet. And so this way you'll learn stuff that actually may not be publicly available to you. Otherwise, normally you wouldn't need to do that, right? So Nikki, sitting right next to me to my left, she's Director of Technology Maturation in the Space Technology Mission Directorate at NASA headquarters. She leads advancement of mid-TRL technologies for future space missions, including more than 100 projects within the Lunar Surface Innovation Initiative and Game-Changing Development Program. Nikki has over 25 years of experience developing and flying new technologies in space and a proven approach for managing complex projects and programs. She has received numerous awards, including NASA's Silver Snoopy and Outstanding Leadership Medal, and the American Astronautical Society Space Technology Award. Welcome, Nikki. Next to Nikki is Shane Connerday, who serves as Deputy Manager of the Exploration and Transportation Development Office at Marshall Space Flight Center here in Huntsville. Shane's program contributions include Commercial Crew Program Launch Vehicle System Office, Orion Launch Abort System, Gateway SCNI, Moon to Mars SCNI, and Commercial LEO Destinations. Shane is the Marshall Space Flight Center point of contact for Exploration Systems, Moon to Mars Strategy, and Architecture Office. Mr. Canaday has served leadership roles in human exploration and development, safety and mission assurance, engineering, as well as SLS and Orion project offices. Shane led Marshall's efforts for the initial NASA architecture review process that concluded earlier in 2023, and Jim Free made reference to that earlier this morning. So welcome, Shane. Jamie Stearns is Cislunar lead at AFRL. So Dr. Stearns is AFRL's Space Vehicles Directorate Flight Experiment Principal Investigator. She coordinates the Directorate's research and development activities in space situational awareness, which I just made mention of, and command and control in support of defensive space operations with expertise in astrodynamics, astronomy, and development of space experiments. And if you want to ask her what she really does, she won't be able to tell you. Next to Jamie is Dr. Seamus Tui. He is the Senior Director for Business Development for Robotics and Space Operations at MDA, Canada's leading space company. So speaking of international partners, in this role, Dr. Tui has responsibility for providing solutions for commercial, civil, and national security missions, including strategy and business development of on-orbit robotics, sensors, and rover technologies. Welcome, Dr. Tui. And last, but of course not least, Justin Cyrus. So Justin is founder and CEO of Lunar Outpost, a commercial space company that he founded in 2017, specializing in space robotics, lunar surface mobility, and in situ resource utilization. Lunar Outpost's flagship rover, the Mobile Autonomous Prospecting Platform, is scheduled to be the first commercial rover to visit the lunar South Pole sometime next year. So you can see this is going to be a pretty interesting group of folks to hear from. The way that we've structured this, each of the panelists is going to spend 5, 6, 7 minutes giving you some background on what they're doing. They may have slides, they may not. When they finish, then it'll be open to you guys for questions. I've got some questions, but I'd rather hear your questions. So with that, I'll turn it over to Nikki.
All right, let's see. Okay, this one hasn't flipped. Okay, good day. We can go to the next one, please. Do I flip them here? All right, good morning, everyone. I think it's still morning, right? Can you hear me okay? All right, so I know we are standing between you and lunch, so we will try to make this dynamic and exciting. Is everybody awake? Okay, I'm going to talk today some about the lunar infrastructure objectives that we have and what we're doing in NASA's Space Tech Mission Directorate. You heard a good bit about that this morning, kind of touched at a very high level. And as he was saying here, we're going to dive down a little bit deeper and look really forward to the questions. So hoping to make this part go kind of quickly. I'm not going to bore you to death with slides, but hope to give you maybe some thought for prompts in the question section. So real quick question, just to make sure everybody's awake. How many people here, well, you heard earlier, but besides what you heard on the panels earlier, how many people had heard of the Moon to Mars objectives before today? Yay, that's great. How many people know how to find them? Oh, that's awesome. That's more than how many people have read them? Y'all, you know what? I think maybe there's a theme here. So we're all like in space. So good. That's great. So we are. There obviously are 26 science. There's 13 infrastructure, 12 transportation and habitation, and then 12 operations. Today, I'm going to focus on the infrastructure side. In order to get to sustainability of any sort, you just really have to establish the basic infrastructure that you need. And you mentioned some of those areas. We've got power, ISRU, mobility, comm, surviving the environment, right? This Moon's a very extreme environment, and big temperature swings, surviving the dust. We call it dust mitigation, not dust solutions, because you can't really solve it. You just have to mitigate it through active, passive, and operational measures. And so we have an excavation and construction. I don't want to leave anybody out because I'll get fussed at later. But we'll talk about all of those. But that's what we're focusing in space tech. As was mentioned, I lead the mid-TRL level, which some people may call the Valley of Death, which I think sounds very ominous. But I like to consider it the bridge between the early R&D and our early stage programs, and then getting to the prototypes and some of the early demonstrations, and then infusing or transitioning that out to the higher TRL for scalability, whether that be to our other mission directorates or other programs like our technology demonstration missions or industry. And also the Lunar Surface Innovation Initiative. How many people have heard of the consortium, the Lunar Surface Innovation Consortium? Yay. Everybody that didn't raise your hand, I meant to put the websites on the chart, but it's really easy. Just Google LSIC, L-S-I-C. It's facilitated by Johns Hopkins Applied Physics Lab, and that is a community. We just had a meeting a couple weeks ago. We meet twice a year. We have monthly focus groups in the 6 different capability areas I just mentioned. And the idea there is to get folks together to mainly talk about what are our technology gaps, what are those basic technology needs and gaps that we need to close, whether that be, of course, by doing demonstrations here on Earth, getting to prototypes, testing things out in the closest to the relative environments that we can get, flight opportunities, suborbital missions, and then also, obviously, lunar surface demonstrations. And so I'm going to talk a lot more about that. Let's see, we'll go to and the code is here. Everybody needs to scan, but it sounds like most folks know how to get to the Moon and Mars objectives, which is great. All right, I'm not going to read these to you, but there will be a test later. So there are 9 lunar infrastructure objectives, and it's really just the things that we were talking about earlier, the kind of common sense kind of stuff that we would all need to live and operate on the Moon. What I think is really exciting is what makes us different from Apollo in a lot of ways, is that we really are going together. That is not just a slogan for Artemis. Artemis is our program. And the beauty of the technology development side that I get excited about is no matter what state I go to, who I talk to, what regions, we all need those basic capabilities if we're going to go to the Moon. You have to have power to operate. You have to be able to access the areas you need to get to. You have to be able to survive the environments that you're in. So all of these things, and especially getting that TRL up the chain, we all have to work together to do that. The other really nice thing about it is there's a lot of applicability right here on Earth, and also with some of our other government stakeholders in cislunar space, whether it be AFRL or DARPA or others. We're doing a lot of work together to get that TRL up. The key is that we do have to get the TRL up so that those technologies can be infused into the future missions. A lot of times it's kind of backwards, but in the general public eye, people think a lot of times like technology is a bonus, right? The technology development or something you could kind of do as a luxury. It's really not. It's the tip of the spear. And by not starting that mid-TRL technology development now and getting it tested in the relative environment, you will not have the option to infuse or scale up for later missions. So all of these areas are very critical today that we're working on these together. So I want to talk a minute about kind of our lunar surface technology strategy that we have. You can see there on the chart, we've got several missions. A lot of those are in the earlier missions there are our CLIPS. I do want to put in a plug for our commercial lunar payload services missions. Those are very, very key, not only for science, but for technology. And so we work very closely together. Those are amazing opportunities to get into that relative environment and test these technologies out and really increase that TRL. So we have multiple missions, but today I'm going to focus on, if you look on the chart there, what says Lift 1 and Lift 2. That's our Lunar Infrastructure Foundational Technologies. We just came up with that acronym. I'm very proud of it. Missions. And so we're going to focus a lot here on ISRU, but the beautiful thing about ISRU is it requires what? It requires power. It's going to require mobility. You have to be able to survive the environment. It's going to require excavation. So all those different capability areas are inherent to being able to meet your ISRU goals. And if we're going to go to the moon, then we have to be able to use the resources available to us there. It's very different than space station. We've learned so much from space station, but that is a very kind of Earth-dependent model still when it comes to logistics and operations. And the moon's going to be different. I mean, it really will require us to be Earth-independent. And so we'll need the technologies to be able to do that. We'll have Lift 1 and Lift 2 to kind of test out those ISRU technologies. Those will come after, if you go backwards on the chart, Viper. I'm sure everybody here has heard of Viper, where there will be ice mining using mobility. And then before Viper, we have Prime that will be going up on Intuitive Machines 2 within the next year. And that will be testing out the mass spec and the drill that Viper will be using on the moon. Once we finished all those missions in Lift 1 and Lift 2, we'll have a lot of information on the different ISRU processes we're looking at, as well as the resources, more information on the resources of the moon and the locations that we want to go to. And we're going to all these exciting new locations that we've never explored before. From that, we'll actually inform our ISRU pilot plant. The pilot plant will be a scalable demonstration of ISRU that can be scaled up and then infused into commercial missions, or NASA missions. I will say ISRU to me is exciting too because it is something that we all want to be able to use. It's a consumable, right? But NASA's not looking to kind of own and operate the ISRU technologies, right? We want to enable those. We want to foster those, facilitate those happening so that we can all get to those resources, whether it be consumables for the crew or propellant, or if we're using those for excavation and construction of landing pads or habitats and structures. So, I forgot to do that part. It maps to 7 of the 9, these missions map to 7 of the 9 lunar infrastructure objectives. So this is why I say these early missions, these missions where we can test out these technologies are really, really fundamentally important. So I talked some about Lift 1. I wanted to let everyone here know we announced it at the Lunar Surface Innovation Consortium a couple weeks ago. We will be releasing very soon an RFI related to Lift 1. I strongly encourage folks to watch out for that. It's going to be on Inspire. It's coming out very soon. And that's going to be an ISRU auction extraction mission. It will be the whole package, right? We're looking at doing a mission where we do the auction extraction, but whoever bids for that will have to make sure you have the power, that you can mitigate the dust, that you have the autonomy and robotics that you need. So it's going to be a very exciting mission. And you'll be hearing more on that soon. And like I said, please spread the word across all the different communities that an RFI is coming out because we really want that feedback. That feedback will then help to inform an RFP coming later for that mission. With that said, I think that's the end of mine. So hopefully that's some food for thought as I turn over to Shane.
Thank you, Nikki, and thanks for having me, everyone. So Shane Cannerday, I'm going to talk through what the ACR process is. It's been mentioned a few times already today. Jim Free mentioned the process that was put in place last January. This is likely not new for a lot of folks based on the show of hands we had from Nikki's presentation, but the spin I'm going to put on this is where the international partner piece fits in and how we're working with our international partner to enable some of the objectives that we've identified through the agency and that we're trying to accomplish, and how the international partners can contribute to those objectives and help offload some of the programmatic burden that we have from the NASA perspective. So again, this is probably repetitive for some, but the pillars that we're using for exploration while we explore, Science, inspiration, national posture. Science, it's fairly straightforward. We're trying to put in place through the ESDMD work, strategy and architecture office that I support, the capabilities to go execute the science that are identified through our objectives. So again, working with international partner for areas that we may have gaps and they want to contribute to Artemis missions on, this is the way we were able to achieve our science. We're putting those systems in place today that as the science evolves and new needs are identified, in the future, we'll have the flexibility in our architecture to accommodate those demands as they come forward. Inspiration, it's fairly straightforward. I'm still inspired by the work we do. I think it's incredible that we all get paid to do some of the work that we are able to do, but I'm told we need to start bringing on our new generation called the Artemis generation and identify opportunities across our population, across international communities. This is a huge challenge that we have. It's what inspires me. We're set lofty goals that are going to be very difficult to achieve. It motivates us, but we're going to need everyone. It's across the U.S., it's across the international community, our partners, that we're going to need to reach all corners and not leave any talent that's available because of some reason that they don't have access to the same educations and desires for supporting the NASA Artemis program. That we need to make sure we are getting the message out, and through this architecture concept review and setting these goals in place, I think it's on each of us to reach out across the communities to ensure that we're doing that, getting our inspiration to our students, to our young people. The national posture piece, so if you study this Venn diagram, the international partnerships is a part of that. So again, that's kind of the area that I'm focused. And one of my roles is working with international community. I do that multiple times a week. I was on a meeting with the European Space Agency this morning prior to coming here. So I'll step through kind of how this applies to our international partners going forward. So this is the why we explored. It's just this one, right? Oh, I might have went too far. All right, so the why we explore. So if we start with our pillars and then identify the who, the what, the when, the where. The who, we think we're putting 4 crew lunar surface and we're going to the South Pole ultimately. That comes with some need for infrastructure. We'll need infrastructure in Cislunar. We need communications capability. Our Gateway program manager mentioned this morning, Gateway's got communications. We're also getting contributions from ESA on communications in Cislunar as we get to the surface, go to the South Pole. One of the resources available at the South Pole is significant amount of time that we have solar availability, which will be our initial missions. But as we expand and try to get more aggressive on what we're accomplishing at the South Pole, the ISRU, as Nikki just mentioned, there's significant power demands in those systems. So we're looking at, as Nikki's group is looking, these nuclear capabilities. Our international partners have identified an interest in where can they contribute in a nuclear realm to help enable, again, what we're trying to achieve at NASA. So this is very connected with each one of these decisions we make. International partners are wanting to participate in our programs, bring contributions to the table that we're able to deploy, again, to solve our problems. So this is what, through our architecture concept review process that we started this year, we call it the ACR 22 because we started in 22 but completed in January of this year. We started the term architect from the right. So we're setting, this is our end goal, and right now it's Mars, but that's not the end goal. But to date, that's what we're working to, is how do we get to Mars? The systems that we're putting in place, everything we're doing should feed forward to Mars. So any of the nuclear technologies, that's expected to be a potential need on the Martian surface, where solar may work better at the moon than it will on Mars. Nuclear can be enabling there. So we're architecting from the right with this chart. Our next chart. Excuse me. Oh, is it? We need to educate some of our users on how to hit a PowerPoint button. There we go. Sorry. Thank you. So we're architecting from the right, but we're executing from the left. So our ACR process, we identified campaign segments. The focus of ACR 22 was the human lunar return segment. That's getting humans back to the moon, but as a part of the human lunar return segment, we have significant contributions already from our international partners. The Orion spacecraft service module provided by ESA. Gateway program is definitely something it's a part of the human lunar return section and our campaign segment, and it includes international contributions from JAXA, from ESA, from our Canadian friends. As we're maturing going forward, this year the focus for ACR is going to be the humans to Mars. We're developing a roadmap to Mars, and we're just starting to have those communications with international partners on what capabilities they're wanting to bring to the table for us to go execute a Mars mission. And we're also starting to focus on our foundational exploration, and that's where we're spending a lot of our time. So that's our multiple meetings per week, working with our friends from ESA, CSA, JAXA, the Italians, looking at a handful of contributions. The pressurized rovers, something that is it's an international partnership contribution. We've got habitation interest. Unpressurized rovers and cargo landers are all part of what our international partners are identifying today, but we continue to work with our international partners to identify new contributions that they may have expertise that we can leverage to help us achieve our foundational exploration campaign segment. And ultimately, this goes to our sustained lunar segment that, as I've said previously, is going to require the significant power infrastructure that we're going to need to execute the things that we're trying to accomplish throughout our sustained lunar phases to enable some of the objectives that we have in the sustained lunar phase. And then this chart, it's not really a chart I intend to talk. It's just each icon as I was studying this chart and prepping for this discussion. Each icon on this chart, some represent decades and some maybe even more decades of work. I know for SLS and Orion, which I've spent time in both programs, I've dedicated a decade of my career to working to achieve Artemis 1 and the payoff on Artemis 1. Again, that goes back to our inspiration and what it does for me. But each one of these contributions, there's a huge international flavor to a lot of these identified here. The pressurized rover, the cargo landers, Orion, program gateway. International partners are going to be critical for us to execute. And we had a huge appetite for what we're trying to achieve, bringing on international partners and guiding those contributions in the direction that contributes the most value to Artemis is going to help enable us achieve some of these objectives that we've got laid out. And that's it for me.
My turn to see if I can use the clicker. So this is a graphic of how the Air Force Research Lab views cislunar space. If you look in the center, you will see the Earth. You will see a geo satellite going around it. This is all to scale. The sun is going around the Earth. It does not mean we are bad at astrophysics at AFRL. It just means this is a useful representation and reference frame. This is showing, truly over the lunar month, the sun rotates around this entire space, creating what we have coined, I think notoriously at this point, as the cone of shame. That makes it very difficult to monitor anything within that red cone, or there's a couple of them if you watch the changing graphic, from the Earth. And this becomes a problem, right? Everything that AFRL and the Space Force Department of the Air Force have done historically has been within that little tiny geo bubble. That's pretty much the space we've cared about, and that's where we operate today. But as our NASA colleagues are leading the way on a sustained presence out into cislunar space, as we're bringing along international partners and we're bringing along commercial, and we're really encouraging a worldwide effort to go out there, in order for that to be sustainable, as Jim said earlier, there needs to be situational awareness of what's going on in that space. And this graphic is really intended to show kind of how we view the problem, how the capabilities that we have today are simply not sufficient to cover that entire space the way that we would like. And there's a whole lot of other stuff in the background of why that's hard as well. And I think at AFRL, we stood up Cislunar SSA research about 5 years ago. We kind of saw this as a coming problem as the Artemis program began to solidify and became real. And we said, wow, we need to be there to support our colleagues. We were grateful when the national strategy codified that research bet that we made when the Cislunar National S&T strategy came out last November, really called out SSA as one of the key objectives that we need to do there. So kind of starting at the bottom of this chart, just for where our heads are at, there's a whole lot of foundational research that needs to be done. A lot of propagators exist, a lot of the algorithms exist in order to do the space object tracking, but we need to figure out what's efficient, we need to figure out what's scalable. We need to do a whole lot of work to figure out how to roll that up and stitch that into what a prototype catalog might look like if you kind of go up to that second layer of this pyramid. There's a lot of things that need to get figured out in terms of how we do that and build the basic framework for what we would even consider a catalog and doing that basic SSA mission. At the same time, everything we want to do, we want to be testing as we do it. So we routinely have collection campaigns. I'll note the SDA Marketplace logo on there. We want to see what role commercial plays in this endeavor. We work routinely with civil agencies. I'll call out Planetary Defense as a primary partner of ours, where the term we've kind of coined is their trash is our treasure. Artificial satellites are noise in the city killers and planet killers that they're looking for. And ultimately, when we start getting better and better at this, we're going to start picking up, potentially asteroids and comets and natural objects that are kind of noise against our baseline of what is it human activity is driving. So we've set up information exchanges, and we talk routinely with them, and that's been a really, really fruitful collaboration. And then as we roll all of this capability up, you get to kind of the shiny object that I think most of you are aware of because we've had a fair amount of press on this. We're very proud of this program. Oracle is our spacecraft that is being designed to go out to the Earth-Moon L1 Lagrange point and actually practice doing this SSA mission. It'll be some of the DoD's first attempts to go actually operate out there. We need to see what kind of communications and PNT that we're going to have out there today. We want to try and understand from an SSA perspective how well we need to be able to do those things in order to be able to relay useful SSA information. And I think that is where a lot of the infrastructure piece comes in. That's where a lot of the partnership piece comes in. We don't want to go out there and have to build our own common PNT networks. We would really like to see what everyone else is doing and how we partner with NASA. We're following LunaNet and those developments very closely. We're following what commercial is going out there to do. And hopefully we can bring this all together and create the capability that we need to really make this environment sustainable. So with that, I'll hand it over to Seamus.
Too daunting to use the slide advance. I'm just going to talk to a blank screen. So I'm in robotics and space operations at MDA Space, the largest space prime in Canada, and we've been historically the prime contractor for the Canadian contribution and to the partnership for first shuttle with the Canadarm, now space station with the Canadarm2, and we're in the process of designing and developing and fielding the Canadarm3, which will go on the Gateway, so it'll move to Cislunar space. In addition, we've been direct support to U.S. prime contractors for rendezvous sensors and also robotic systems for programs like Orbital Express and RSGS and OSAM, and we're now looking at supporting CLD. So all that work that we've done in LEO, is starting to move now to Cislunar space, first with the Gateway Canadarm, but also things like anything that moves mass and does work robotically. So whether that is Canadarm on Gateway, moving things around the exterior of Gateway, or transferring things from one platform to Gateway, or even inside Gateway, looking to move mass around inside because it is a partially crewed volume as opposed to the station, which is 24/7, 365 days a year. So when the logistics module or some kind of logistics transport docks with Gateway, how do you move the cargo around with no crew on board? We're also taking that to the surface, looking at supplying robotic systems and navigation systems to things that provide surface mobility and surface relocatability. So the difference is mobility is things you do while you're moving along the surface, and relocatability is that mass transfer, as DARPA, I think, calls it cross mass, where we're taking mass from one location to another. So surface to platform, platform to platform, platform to surface. So we're hoping to support the Canadian contribution to Artemis called the Lunar Utility Vehicle. And what that is, that'll still be determined, but the government of Canada is committed to developing a large rover that will be part of the infrastructure on the moon to move things around and to do great things to help build the infrastructure on the moon.
Awesome. All right, so it looks like they got my slides up. I was a little worried because those came in a bit after the deadline, but thank you, Jim, for getting those on the slide deck. So my name's Justin Cyrus. I'm the CEO and founder of Lunar Outpost. I'll keep my slides short so we have plenty of time for question and discussion. But just to introduce Lunar Outpost, for those of you who are not familiar, at Lunar Outpost, we create mobility and robotic systems to enable a sustainable presence here on Earth, on the moon, and on the Martian surface. Now, to give you a little bit more idea about the traction we have and what we've been up to over the course of the last 5 years, we have 4 missions currently headed to the moon. First 2 as part of the NASA Eclipse program, which we're quite excited about. So our first mission is a fully commercial rover that is actually profitable. That's flying on IM-2 alongside Nikki's Prime 1 drill, which we're quite excited about. And that will be the first commercial rover at the lunar South Pole. First sale of space resources in human history for $1, which we'll be delivering on time and on budget, which we are quite excited about. And that leads us to the second mission. So second mission is heading to Reiner Gamma. So that's a magnetic anomaly on the surface of the moon. We're teamed up with Johns Hopkins Applied Physics Laboratory, and that will be launching as part of IM-3. So those are launching on SpaceX Falcon 9s, landing on Intuitive Machines Nova C landers. Our third mission is another fully commercial rover that is also profitable that we'll be announcing here shortly. And fourth mission is going back to those international collaborations. Australian Space Agency teamed up with NASA to go collect resources on the surface of the moon and deliver them to those resource processing facilities that Nikki was mentioning. So that gives a quick idea of the traction, but also I think this slide really shows that exploration to that sustainable economy transition quite well. So our first mission, truly it's just proving we can do it. Proving we can get to the lunar surface, drive around with a rover at this cost point, and still be effective. And we have over a dozen commercial customers that are a part of that mission, with the anchor tenant being Nokia, which many of you are familiar with the story, LTE being delivered to the lunar surface to test out intralunar surface communications. But as we start moving along the timeline, we start introducing more and more advanced capabilities. So second mission, you have waypoint autonomy, which allows you to be more operationally efficient. Third mission, it's full lunar night survival. And also some advanced dust mitigation technologies. And by the fourth mission, you're introducing that robotic manipulation alongside intra-system collaboration. So not only interacting with other landers, but other robotic systems on the surface of the moon. So by introducing these more advanced capabilities, that's really where you start seeing those cost-effective price points, which I'll talk about here in a second. That being said, it's not only robotics that are advancing quite quickly with the likes of MDA, Lunar Outpost, and many others, that in-space transportation, those AI/ML layers, those robust energy sources, those are all enabling a new cost point of infrastructure. And that cost-effective infrastructure does mean sustainable space, which some of my fellow panelists mentioned here earlier as well. And so where that cost point comes in is extraordinarily important, because the lower cost, the more commercial players, the more commercial stakeholders you can start bringing into the market. And by enabling a robotic workforce to help set up that infrastructure not only on the surface of the moon, but in cislunar space with the power, communications, roads, habitats, launch and landing pads, et cetera, that's how you enable astronauts to go do what they're best at: the critical thinking, the problem solving, the creativity, and the decision making that is needed for us to have a truly sustainable presence in space. So that leads us to where we're headed next and what this future commercial economy looks like. That cost-effective infrastructure, as I mentioned earlier, the lower the cost point, the more commercial stakeholders you can get as part of the market. So we want to leverage that infrastructure that's being put in place by NASA, by the DoD, by DARPA, by others, to enable those commercial applications on the surface of the moon. So leveraging that infrastructure to unlock the commercialization of cislunar space. And what that means is a lot of these business cases start to close. Not only lunar tourism, space resources, in-space servicing and manufacturing, those all start closing quite quickly when you have supporting infrastructure in space. So today we have a couple $100 million in interest in providing services out in space, and that's just going to grow as more infrastructure comes online and as more opportunities become available due to the transportation layer in cislunar space. So as I promised, I'll keep this quite short, but I do like ending my talks with hardware. So these are our first 2 rovers that are getting ready to go to the lunar surface. They have been delivered over the course of the last couple months, which we're quite excited about, fully spaceflight ready, about to be integrated into those Intuitive Machine landers. These are a few of our larger, more capable systems, our Break the Ice rovers, which just mined 12 metric tons as part of the Break the Ice challenge, which was quite exciting. So that was the maximum set by NASA. We hit that daily maximum, which we are quite proud of. And then we did just deliver another rover as part of a NASA Luster program to Colorado School of Mines, and they're going to autonomously build, level, and compact a launch and landing pad. And those 4 rovers were all delivered over the course of the last 2 months. So it's been quite a busy time, but we're very much looking forward to our next challenge. So I'll end my talk there, and yeah,
Thanks, Justin.
thank you.
So I promised you an excellent panel, and they have delivered. I did want to reflect on a couple of things. Nikki talked about getting the TRL up for eventual mission application. You heard SOX talk this morning a little bit about the conundrum. When does ISS retire? When are the commercial alternatives ready? How do we invest at the right level as the government to enable? Justin was just talking about you need a certain level of investment in infrastructure to make the business cases close. This is not simple stuff, right? This is complex for the government to figure out how to do. Really impressive what all the panelists are involved in. Nikki talked about dust mitigation. You might think that's kind of not interesting. It's actually a pretty fascinating problem that NASA is trying to solve. And Justin's not going to be able to do very much if dust is overwhelming all the machines that are on the surface of the moon. So anyway, I'm not going to go through all the different interesting things that the panelists talked about. I also heard multiple times about international partners. So again, you're hearing that. I started it off, but each of them, or not all of them, but most of them talked about that. So let me stop and let's open it up for questions.
Hello, so you guys were talking about dust mitigation and advanced ways to deal with that. What are some of those ways? I'm kind of curious to see what solutions you all have potential solutions, excuse me, that you all have come up with.
Yeah, so actually, I was not really teasing when I said dust mitigation versus dust solutions because you can't totally solve it, right? You have to learn how to live with it. And the lunar regolith is really harsh and abrasive. We learned a lot from Apollo. When they came back and they really looked at the suits, they had thousands of those tiny, tiny little cuts into the material. So we are exploring active, passive, and operational measures. Some of these are new materials. We actually did a really cool kind of technology search through our early stage program to look at different industries terrestrially that deal with similar type of things, whether it be the mining industries, medical industries. We've got some really kind of cool technologies that apply here as well. So we have some different kinds of new materials. We have coatings. You have operational measures that you can put in place. And you have we're flying on one of our upcoming CLIPS missions. We just delivered this hardware, electrodynamic dust shield. And so we have 3 different categories of things that we try. We will have to think about this for any kind of rovers, for habitats, for suits. I mean, pretty much everything that the crew is going to be doing, or our hardware as well. We have a little pilot excavator that we're demonstrating, and it comes up in all kinds of different ways. One of the key things is having imagery and being able to see where we're going, and so you have these little cameras on there. And the question was, what do we do if the dust gets in the camera lens? You have this really simple, or I guess fundamental problem. And now you realize, okay, there are no humans. This is a robotic mission. You've got to make sure, this blocked lens is not going to keep you from doing your whole mission. So this team actually came up with a very clever idea where if one lens gets covered, I think they've stacked 3 or 4 lenses together, and it's just a simple technology where if it gets covered, they can eject the one lens and one is under it, right? Same thing goes with like the solar panels on this little excavator and on a lot of our hardware. If it gets too much dust covering it, they're not going to be very effective, right? So you have to have little swipers or have a closure mechanism to remove the dust. So looking at a lot of different ways of doing that, have a lot of technology transfer that we're both putting out, and then technologies from terrestrial industries that we're infusing in. And we're working across, all of our different mission directorates. As I mentioned, space technology works with our exploration systems and our science mission directorates as well as industry. So we had Lunar, he mentioned Luster, Justin mentioned Luster. It's our Lunar Surface Technology Research grants. We had a lot of dust mitigation there. We have small business awards. We have tipping points, all kinds of, and prizes and challenges as well, where we're working from everyone from the crowd sourcing to STEM to larger companies as well.
And just to add on, I think Nikki covered most of what I was going to say, especially the coatings, the electrostatic dust shields. Those are really the cutting edge of advanced dust mitigation. The one other technology we've been looking at is seals. So materials for seals in cryogenic environments, whether you're looking at motor seals, whether you're looking at seals on your solar panels, or whatever else you need to do with your spacecraft or your spacesuit, those seals become extraordinarily important and do start wearing down quite quickly because of the abrasive nature of the dust and because of the extreme changes in temperature that you deal with day in and day out. So seals is the only other thing I'd add to that list.
So one thing I'd also like to point out is, a lot of people, when they talk about dust mitigation, they're talking about, survival of their system. One other area that we're looking at is when you talk about long-distance traverse for sample collection is cross-contamination of samples. So the scientists are really concerned about, when they collect a sample at one location, they want to know everything that's in that sample is from that location and not from anywhere else. And so if you have a simple scoop or something, that picks up a sample, puts it in, does that scoop still have dust from that first scoop when it does the second scoop? And you're talking samples which are, grams, and so these things are important. So we're looking at not only technologies for, looking at how our arms survive using seals, using covers, using active measures, but also how you would go about, cleaning sample collectors off so you don't do cross-contamination.
We have one question online here for the panel, and Noah Hassett is asking, what is the easiest way for a young professional to enter the world of cislunar or lunar industry work?
I'm going to start. Sorry. I'll turn it. There's so many ways. I started as a student. I actually went here to UAH. This is like amazing being here. And got 3 degrees at this school. Would love it. So, and I started as a student. We have so many more ways now. They're just very exciting. One, we have our all kinds of different STEM opportunities. I mentioned, for example, Luster. So you have grant opportunities. We have Big Idea Challenges that's out now, our Breakthrough Innovative Game-Changing Challenges. We have acronyms for everything. So lots of different challenges and opportunities like that. In addition, we have, Pathfinders, our internships, and ways that you can get involved. We welcome young folks because, don't tell anybody, but sometimes when you've been doing this a long time, you can kind of get groupthink, and that's inevitable, right? And I cannot tell you how many times we've had a crowdsourcing challenge or a STEM challenge where we're all sitting around the table reviewing these proposals from students, and we realize, oh my God, we never thought about that. Like it would be some of the best ideas, and it's just that they started from a new place, right? And we had already kind of ruled that out. And so it's amazing. So we have all kinds of opportunities. I will also just plug the Lunar Surface Innovation Consortium. If you go to the APL site, it's free. We have all kinds of student poster sessions, and we have the monthly focus groups. We can get in and listen and network. Even though they're virtual, we have all kinds of networking tools where you can meet real space professionals across all the different sectors, different government sectors, as well as industry and international folks. So that's something you can do anytime and invest as little or as much time as you want.
I would love to jump into. Air Force Research Lab also has all kinds of opportunities to work in cislunar space. So we have a summer internship program that goes down, I think, as young as like late high school students we take even into the program, all the way up through anyone who is still obtaining a degree. You're eligible to come work with us for a summer and a paid internship. We also partner across a lot of the DoD-wide efforts, like the SMART program, the NDSCG. Don't ask me what that stands for. I'm happy to find that information and make sure it gets out. And then we also have National Research Council postdocs. And I think, my slide had all kinds of logos with different universities that we work with, things like that. So, there should have been a blank on there. Your university here, there's a lot of ways for young folks, for students to come work with us. And those are super important to our pipelines. And I think they're super important to getting skill sets back that we haven't worried about in a long time. We're seeing a resurgence in astrodynamics that we haven't had in a long time. We keep hearing certain things are solved problems because we've had too much success. Well, now we have new problems, and we need those skill sets kind of rejuvenated. So, we're really looking at today's students to come help us solve those.
One quick thing I'll add, challenges, projects, anything you can do to get hands-on experience. So when we won the Trailblazer program, we're one of 2 companies competing to be that phase 2 company that puts that rover on the moon. But the first thing I did was go to the Australian Rover Challenge. And it was a group of, I think, around 100 students. Not all the students from each team came, but the winning team, I walked up to the winning team, I walked up to the second place team, third place team, and I invited them all to dinner. And I got to know them, really awesome group of students, really impressed what they were able to do as students. And when we were hiring the first 15 people out in Melbourne, we got 50% from industry, so NASA experts, industry experts from Lockheed Martin, ULA, Boeing, Ball. But then the other 50% we got right out of university. And where we got those students was each student I met from that rover challenge. So if you are a student, make sure you're getting involved. There are a ton of opportunities. NASA does an awesome job of getting those challenges to the point where you don't need a lot of overhead, you don't need a lot of supporting infrastructure, and you can get out there and compete.
One last thing on that. I just feel very passionate about this. So don't wait for the perfect opportunity. There's so many different opportunities. Sometimes it gets overwhelming when you go do Google searches or whatever, and it's like, oh my God, which one do I try? Just pick one. Just get out and meet people, do networking, take advantage of the opportunities that are out there, but don't get too overwhelmed. Like, play the field a little bit. When you're young, you get to get all kinds of different experiences that way.
And I would add to that is, I think the most important thing is to be open to opportunities. That you never know when the right one's going to come along, but it doesn't really matter. Jump in, and the experience you gain, even on a program or an opportunity that doesn't go very far, will pay off in the end. I had zero academic background in space systems. I was a naval architect. I did marine systems, and when I went to go work for a company, that's what I did. I did high-speed craft. I did submarines, and an opportunity came to work on a 2-stage to orbit reusable launch vehicle, something that nobody has ever done, and jumped right in, and that became a career for me in space systems. So be open to opportunities that present themselves, and don't be afraid to jump in, even if that particular opportunity doesn't succeed, or the experience you gain will then lead to the next one, to the next one, to the next one.
Yeah, and I'll add, just to make sure we close out everyone here, there's a fundamental assumption, I guess, that we're pursuing degrees in STEM fields, so that would be an initial take. I don't think that was mentioned, but pursue degrees in STEM. Nikki mentioned the Pathways internship, so NASA has multiple internships that go out on a recurring cadence that definitely encourage anyone that's interested to apply there. But if we do Artemis the right way, this commercialization, this making it more available across the country, there should be companies in your area that are working in the space field. Reach out to those companies. We should broaden and disperse some of the work that has historically been located in centralized locations. So that's the intent of what we're trying to do with the pillars that we're using for explorations.
So you may have picked up the passion from the panel on this topic, and in general, from a space and cislunar point of view. every one of the sponsors that is involved in this conference, I am sure, has intern hiring plans. So there are many opportunities, Aerospace Corp to be included, whether they're high school or college. So there are just a plethora of opportunities for primarily STEM-trained young aspiring, interested.
Although we need
space
lawyers, business folks, comm folks, STEM, yes, but we also,
Yeah.
it takes all of that ecosystem to make what we do work. And I do want to make sure to mention we have internships for those too. Yeah.
Excellent. Other questions?
Yes. This question is not to suggest that economic drivers are the end-all, be-all of exploration, but it is at the center of that Venn diagram we saw earlier. One of the objectives was ISRU demonstration capability. And so I'm wondering, beyond water, are there other currently known materials for resources and prospecting?
Heck yes, and raise your hand in the room if you want to talk to this gentleman during the break, because you are working areas like that, because I guarantee you there are a bunch of them, including Corky Clinton over here. I was going to wait for him. So absolutely, water's the obvious one, but we can make things like propellants. Also, just using the actual regolith itself for construction, and not just for things like structures like habitats, but landing pads are really important. Just imagine if you could actually, quote unquote 3D print, right, a landing pad in these different areas. If you had an autonomous robotic system that could go different places on the moon and print the landing pads, roads, berms, all kinds of things. So yes, between the consumables for the crew and propellants and excavation and construction type materials, there's a lot we can do.
Yeah, I would add to that, when you look at the regolith, one of the largest components of regolith is oxygen. So it doesn't have the hydrogen part like, water does, but there's a heck of a lot you can do with oxygen and all the different metals that are constituent in the regolith, pulling off the volatiles, even things like, helium-3, that who knows may have a use in the future. Very exciting discoveries to be made of how to utilize what is extracted from just the regolith that is in different parts of the moon.
And I'll just add too, this is a good example of where industry and NASA partner to use our mutual strengths, right? So industry's developing the technologies, but we do have a lot of NASA experts that have been studying for years and have, really cool geology degrees studying the lunar regolith and the properties of those. And how do we make simulants that we can test here on Earth to make sure these technologies work? How do we keep consistency and standards and quality control within those simulants? It's kind of the Wild West of simulants out there. So we have a lot of experts that we partner with these companies and offer those type of skill sets at our different NASA centers too.
Last comment on space resources. So I could talk about this for hours, but I'll keep my comment quite short. I think Nikki covered it. Seamus also did as well. Solar wind implanted volatiles, oxygen in the surface of the moon, but then you do have building materials. Some other materials that weren't mentioned, the moon has been peppered by asteroids for billions of years, right? And these asteroids come from not only all parts of our solar system, but other solar systems as well. There are many valuable materials that can be extracted from not only the key locations at the lunar South Pole, but at other locations in more equatorial regions as well. So the opportunities are truly endless with space resources. And if we are able to access them, it is going to be a pretty fundamental step change for humanity in terms of the resources we have access to and how we utilize resources back here on Earth.
All right, I think it's time that I wrap this up. So let me just leave you with a couple of key points. We're talking about Cislunar, so I'm taking you back to Cislunar. Is it the next great technology testbed? Is it the next great space proving ground? Is it the next great economy? Probably all the above. Let me turn it over to Kyle.
Hello, everyone. My name is Kyle Hughes. I'm currently a sophomore student here at UAH, and I'm majoring in aerospace engineering. I'm originally from North Attleboro, Massachusetts, and I'm here looking forward to working in aerospace structures. We'll now make our way over to the Student Services Building for our luncheon programming. Please make your way across the quad, make your lunch table, plate, and take your seats. Thank you, everyone.